Hi everyone, welcome to the channel. In today's video we're going to be looking at integration and how do we use integration by parts. So here we have our example. You'll see that I've labeled it I today because the calculation is going to take quite a long one. It's going to be quite a long one today. So we've got the integral of x cubed times the natural log of x plus 4. Okay, so the first question we ask ourselves is this a straightforward integration question? Is it just standard? Can I just look at it and know what the answer is? And the answer is no, because you've got x cubed here, you've got the natural log, so you know you've got two different functions multiplied by one another. So you're sitting with a product, essentially. Then you ask, okay, so if I've got a product, is part of the product the derivative of the other part of the product? And in this case, no, it's not, because x cubed is not the derivative of ln x plus 4 and vice versa. So the next thing we have to use is integration by parts. So that means that we need to find a u, figure out what u is, and also figure out what the derivative of v is, right? And we recall integration by parts says if you have uv dash, that's going to equal to uv minus the integral of u dash v. Right, so you remember that's your formula. Now this formula is usually on your formula sheet, but if you do it enough times you remember it. You don't need to look at the formula sheet. So the question really is, what is u and what is v dash, right? So when we look at this, we are going to choose, I'm going to choose u to be that and v dash to be x cubed. And the reason is, if I did it in reverse, if I chose v dash to be the natural log, I'm not going to be able to find the function of v. So this is why I've done this. So then the derivative is going to be x plus 4. And here you go from the derivative to your function, which means you need to integrate. So that's 1 over 4 x 4. Okay, so then when we use integration by parts, we end up with u times v. So it's going to be 1 over 4 x 4 times the natural log minus the integral of, I'm going to take the constant out, and I end up with x4 over x plus 4 dx. Okay, so that's what I've got. So the next step I have to do is I now need to find what the integral of this is. I need to find what this is over here. Okay, so then you go through the whole procedure again. You ask yourself, is this a straightforward integral? Is it standard? Can I just look at it and know what the answer is? And the answer is no, I can't. Is it the product? Well, you do have x4 times another fraction, 1 over x plus 4, but the one is not the derivative of the other. So again, that's not on your formula sheet. So then, can you use integration by parts? Well, you could probably try, but I think it's going to become more complicated because 1 over x plus 4, you know, if you find the integral of that, it's just the natural log. So you're going to find yourself going into circles. And it might work, it might just take a bit long, but a lot of integration is just about manipulating the function that you're working with. So you want to manipulate it into something that is easy to integrate. Now, because you have a numerator and a denominator, it means that you have something that says x4 divided by x plus 4, right? So you have a quotient, right? And you have a divisor. So now you can write this out. You can use long division in order to change the way this function looks, right? So I can say that x4 divided by x plus 4. And this long division you actually did at primary school, except you used numbers. Algebraic long division works in very much the same way, right? So what we do is, we take x, the first part of this expression, and divide into x4, right? So that means I'm going to say x to the power 4 divided by x. What's left? X cubed. Then I'm going to say x cubed multiplied by the first part is going to be x to the 4. X cubed multiplied by the second part is going to be 4x cubed. Then we say the top minus this piece. So we're going to get 0 for the first one and minus 4x cubed, right? And we continue like this until you can't go any further, until this x doesn't divide into this expression anymore. So then we say x, the first part of x plus 4, divides into minus 4x cubed, and it's going to be minus 4x squared. Then minus 4x squared multiplied by the first part is going to give you minus 4x cubed. Minus 4x squared multiplied by the second part is going to give you minus 16x squared. Then minus this expression. So that's going to be 0, and this is going to be 16x squared. Then again, you repeat yourself. The first part of this expression is x, divides into 16x squared, and that is going to be plus 16x. 16x multiplied by x gives you 16x squared. 16x multiplied by 4 is going to give you 64x. Okay. So you'll see now that you're just repeating yourself. You're doing the same thing over and over and over again until you can't go any further. So we say minus this, makes that 0, minus 64x. X divides into minus 64x, minus 64. Minus 64 multiplied by x, minus 64x, minus 64 multiplied by 4 is minus 256. Then we say that minus that. This is going to be 0. That is going to be 256. Now, if you check, you try to repeat it again. You take x divides into 256. It can't go, right? Which means that you are sitting with a remainder. That means that x4 divided by x plus 4 is equal to x cubed minus 4x squared plus 16x minus 64 plus a remainder of 256 over x plus 4. So then you'll see the first part of the expression is just what we found here, right? And it means that we have now changed the form of the second part of that integral. So you recall we had found that our integral is going to look like a quarter x ln x plus 4 minus 1 over 4 x4 over x plus 4 dx. So we've changed the form of this part so that it would look like this. X cubed minus 4x squared 16x minus 64 plus 256 over x plus 4. So that's what we've got now. And this integral is a lot easier to find than this fraction here, because the first bracket, that is straightforward integration. You can look at it and see what it is. And the second part, that's just the natural log. The integral of it is just the natural log. So what we end up with is quarter x4 then x plus 4, 1 over 4. This integral is going to be 1 over 4 x4 minus 4 over 3 x cubed, 16 over 2, which is 8, x squared minus 64x plus 256 natural log of x plus 4 plus the constant. Right? I didn't manage to get everything onto the screen, but this is what your solution will look like. So the biggest thing to remember when you are doing integration is, firstly, are you looking at a standard integral? If you're not, are you looking at something that you can find on your formula sheet? Again, if you're not, you want to find ways to change the form of your function that you're working with, so that you can use integration by parts maybe, or you can change it by using the long division method. You may be able to use partial fractions. Again, you are only changing the form of the integral so that you can find the integral either by standard form or find it on your formula sheet. I hope you found this video helpful. I will see you in another video for another example. See you soon. Bye.